science, which means that we are not bound by certain variables that never change. So computer science, and especially machine learning, is always about a trade-off, right? In machine learning, we could say that the trade-off is always bias and variance, overfitting and generalization. And that's like the basis of everything, right? That's what ideally everyone would want to convey to the students. But the second thing, and main about when designing a machine learning class, is what do we aim? So do the students that come in to our module, whether it's undergraduate or postgraduate, do we want to create a sort of cohort that is going to drive towards getting PhDs? It's going to drive towards going into the industry and applying the knowledge we gave them, or somewhere in between? The general idea that I've seen throughout the universities I worked in, especially Strathclyde. Strathclyde University is based in Glasgow. It's a very business-oriented university. And their goal is always to apply knowledge on the higher level, apply it into business problems, right? So they're not so much interested in teaching students the basis and everything around the science, rather than getting them to apply it whenever they meet a new problem inside their industry position. But is it bad or is it wrong? And this is like, is it proper or improper? Yes, Ivan. Okay, maybe it wasn't something. Anyway, so when moving on to University of Southampton, where they had like a more strict Master of Sciences, the professor there was so focused into teaching the basis and the intricacies of all the operations happening in the middle layer of a machine learning pipeline, that the students were not able to apply that knowledge in any problem. They had to create a separate class where the students would go in and get taught into whichever development language they had, how to apply that knowledge, right? But that professor is by no means a bad professor, right? Because he's the one that taught the students that created the deep learning networks. So these two different approaches, and we have the middle ground here at the University of Southampton, which although we have students from Asia coming in, where they might have let's say, we have a data science master science project. So this project is not about people coming in from computer science. It's about coming in from people from economics, people from mathematics, people from physics, because data science is so widely adopted now that all kinds of disciplines want to get into, right? So the middle ground is what we have here. We have some preparation classes for the students that are not familiar with the tools that we're going to use. So we might have some R, we might have some Python, and we create 1 or 2 months before the whole postgraduate studies start. We invite the students here to study these preparatory classes, right? Similar to how English are taught to non-English native speaking people. And I think that these are the 3 options, right? The 3 main options on teaching machine learning. You've seen that we uploaded some slides from Professor Carlis Lourdas and Choufras, which are more focused on the mathematical side, not so as the slides from math though, or inspired from Andrew and G. Of course, it was going to be full of math anyway. But still, it's only one part of the whole teaching aspect, right? The ideal teaching would be complemented by a certain level of labs in whichever language the professor or the whole module coordinator deemed important to the students, right? And that's about the introduction I want to go into. And let's start by hearing everyone's thoughts on how they experienced machine learning and how they, and most of all, the professors who are going to teach it, what are their plans on teaching the module, right?
Can I say something? Giannis. So I'm Marcelo Bonzango. I'm from Leiden University. So I feel that I have a call on what you say, because Leiden University is a research-oriented university. So when we teach at our master level, but even at bachelor level, when we teach, we are always oriented towards research. There is a field which is called computer science, and the word science is what we try to defend. That is, we want to advance the field of machine learning in this case, with trying to find new, better algorithms, try to understand how it works, why it works, try to find, for example, in the field of automated machine learning, try to find way to fine-tune all the parameters which are needed. And there we always try to find this in a scientific manner. So yes, applying is very important, absolutely. So we don't have to forget this. I completely agree with you on that, but we don't have also to go completely on the other side. That is, we don't have to forget that the computer science is not just applying data science or whatever to other fields, because we are indeed a field in the middle, but we are not, we have to be, how can I say, self-consciousness that there is the field, our field is a very important field, and we don't have to stand back and say, we apply to that. The same like astronomy or physics, they have two separate parts. There is the experimental physics and there is the theoretical physics. And within that, they just live together very, very well. So that's exactly how I see in computer science. So I think we have to try to find the two different aspects and live together. But of course, both are important. And we have to be also convey the message to our students, that the new generation, that computer science is an important field and it's not just applying. And we don't have to teach only technique and learning how to use Python, for example, because in 10 years, maybe Python will not be anymore there, and there will be another language. But the concepts which are behind Python, that's are very important. These are the things which you have to learn. And then they will go to apply, of course, because most of them will go to work in a company or somewhere, and they will have to apply that. But they already have what is called in Latin forma mentis, that helps in try to learn new languages, whatever it comes. Yes, okay, that's just my 2 cents.
Definitely, like it makes perfect sense. Obviously, this is academia, right? We're not sort of like technical schools where we want people coming in and getting out so they can only apply the knowledge. And it's computer science. It has science in the side, right? On one word is science, the other is computer. But the thing is, here are some stats from the UK, right? Out of 100 students that go into the master science postgraduate studies, only 3% goes into their PhDs. Out of that 3%, only 2% goes into an academic career. So my question, like, and it's not like a question to be answered, more like a rhetoric question, like, if we consider like a sort of like polarity spectrum where we have application and we have theory, right? Is there a slider we can drive towards each side depending on the level of studies? So whereas in an undergraduate study, I would go and try and be more applied, right? I really want people to go into master studies, and I really want the best of students go into PhD studies, right? And I want them to contribute, and I want them to be, of course, like have prospective students under you, like you create sort of ties with them and everything. But since we know that out of 100 students, 80 students are going to go into industry, what do we want to do? And this is like sort of like the way we are thinking when we create a module, right? There has to be a balance, and definitely the balance is sometimes more on the science side, sometimes more on the other side. But there is no right or wrong, right? It's always a matter of perspective. So, for example, if you give me Andrew's NG notes for machine learning, I'm gonna say, oh, they're full of math. If you give them like to a mathematics professor to teach them, he's gonna be like, okay, that makes sense, right? It's a different perspective. It's not right or wrong. But in the end, it's all about the students, right? What do they want to achieve? What do they expect out of the module we're offering, more or less?
That's right. But what I'm saying is only we have to be careful not to go too much into teaching a technique, one single technique, one single way of using a system, and that's it, because then it becomes a training. And that's what I don't want to go, let's say.
Definitely, definitely. Makes perfect sense. And it's one of the goals like of academia, right? To create individual critical thinking people into community, right? That's our goal anyway. Any other thoughts?
Okay, maybe I say some. It's just your definition of computer science. Computer science, for me, is the science of applying computer or the science about how we can apply the computer to the real world. But if you want to apply the computer to the real world, you need to understand the real world first. Right. For example, you want to, for example, in our field, AI, when we need to understand what is intelligence. If you say my system is intelligent, then we need to understand what is intelligence, right? So in that sense, our field is a science because we have to model the real world around us. But we have to model. We want to model it in such a way so that we can apply the computer and implement it on the computer. That's exactly why you say, is it applied science? Yes. But on our side, it's science because we need to explore the world and understand it. For example, if you want to talk about reasoning, then you need to understand how humans reason, right? Yeah, but of course, the computer allow us to sometimes to do reason better than human because we got much more, the computer got much more memory. Therefore, we can do data science. Human cannot do that, right? But on our side, women are extremely good at dealing with less data. So if you give a computer a little bit of data, the computer is kind of useless, right? But the woman can quickly discover the system below. But anyway, so I think machine learning is something new, yeah, because it does something that women cannot do, right? Yeah, in that sense, yes. But on our side, machine learning is very weak when you apply it to understand natural language, for example, right? Yeah. When we a sentence like what we discussed now, we understand immediately. But until it would take I don't know how long for system of natural language understanding to appreciate to carry out this kind of understanding. Okay? And even though what we say understanding is also very. For example, when you write a novel, different people will enjoy the novel in a different way. So therefore, understanding here is not only logical understanding, it's also related to many other things, right? So therefore, to apply the computer, you need to model the world. To model the world, you need to invent all kinds of theories, okay? Right, so it's just a question. So therefore, I don't think that the computer science is only about algorithm. Because when you talk about algorithm, you will immediately be asked, is your algorithm correct? How do you know that your algorithm is correct? You have to have a model of a problem you want to solve. And then you explain that your algorithm actually solve a problem according to these models. Right? So it is like we spend about 20 years, let's say from 1960 to 1990 to try to understand programming language. Well, we wrote all kinds of programs at this time, even to control nuclear missile and all kinds of dangerous stuff. But it took a long time for us to understand what a program means, right? So for that's basically just a point for discussion, but not really related to the topic.
Well, certainly, in my opinion, definitely computer science is not something we put on rails, right? It's not something, it's more of an abstraction, right? And this is why we can apply all the different processes and the knowledge and the way we separate a problem into small different problems each time. This is how computer scientists think, right? This is why we can work with one language one day and continue working with another language the other day. This is why we can take methods that work on images in machine learning and apply them in text, and go back and take the methods that we apply on text and apply them on images and so on, right? This is why we have signal processing, and we apply that to machine learning as well. This is what we do, right? It's a form of abstraction. And also another thing that's very important as well, sometimes in machine learning classes I've participated into, there's sort of like, how can I say it? Sorry? Oh, okay, anyway. So there is sort of like a distinction of machine learning in images and machine learning in text, right? But machine learning is data agnostic. What we do is how we best prepare the data we're getting our hands into. And please give me a moment because someone is knocking on my...
He said, please give me a moment because something happening. Okay, I guess we can wait a moment for Giannis to return.
I think someone was knocking his door.
Oh, I see. Okay. Welcome back, Giannis.
So that's what happens when you work from home, right? Anyway, so as I was saying that machine learning should be data agnostic, right? We don't, there are some like fundamental examples where you have to teach like the number, the NIST data set and show the examples and stuff. But then again, and obviously there are some methods, like newer methods, like adversarial networks where they can be applied into text. But definitely, when you teach those stuff to students, we expect from them the next step, right? That's what we want. That's what we're eager for. And as human beings, right? As we grow older, our IQ drops and our experience grows, and we make decisions based on experience. And what we want from students is we want their new unprocessed intelligence to go into the problems we've been dealing all these years and apply new methods, right? And I want to hear more thoughts on the stuff, right? What are your opinions on the ideal machine learning module? Would it be complemented by actual programming? Would it be something that you would do in a separate module and stuff like that, if it makes sense?
Okay, well, if nobody else wants to jump in yet, I'll give it a shot. So thanks, Giannis, for the questions. I think from the goal of our program is that we would like students to be sort of in that middle ground where they could go into industry and be successful, or if they chose, they could go on to do a PhD in computer science or data science or some other related field. So yeah, I think we're looking for that middle ground, right? And I think from my point of view, what I see for the students that we've had in the past that have gone into industry, what having a rigorous background in machine learning can offer them is that when they approach a problem, then they immediately try to answer these fundamental questions like, what is the objective function that I'm gonna use in this particular problem? What are the data that I have available? And then what's the model that's going to put those things together, right? And then the actual tools that they might use from there is just they can perform the task with any tools that might be available, or that might be the normal platform within that organization. So I think the skills that are important for future research in machine learning, and the skills that are needed on the job for a data scientist are not so different.
Yep, definitely. Like here in our university, we have both a machine learning postgraduate course, and we have a data science course, and they both have like sort of 30 to 40% module overlap. So there is definitely like some classes that are can be taught into data science students, and more theoretical machine learning students, right? Definitely 100%. Another thing is that when I was working as a lab assistant during my PhD at the University of Thessaly, the department was computer science with application into bioinformatics, right? And there was a huge discussion going on from students that when we graduate from the university, we are neither computer scientists, neither biologists. So there is something that, if taken in the context of machine learning, right, is something that needs to be addressed as well. You need the students that go out, as you say, to be able to apply their theoretical knowledge to whatever tool they have available. But the middle ground definitely needs not to be separated from both sides, right? And what I mean is like not students that are both not so familiar with the theory and not so familiar with the tools as well. And these are some of the dangers, like when you do this sort of multidisciplinary topics, right? Because machine learning pertains to computer science, definitely, but in its core is mathematics, it's statistics, right? So if you have students coming in from, let's say, statistics, and you show them the theory, they're going to be way more familiar than someone coming in from applied computer sciences, right? So when designing such a course, we need to be aware of these kind of student expectations and our own expectations as well, in a sense. Feel free to interrupt me, guys or girls. I'm like open to interruptions.
Hi everyone, I'm Varalat from KKU. So can I ask you? So for now, I thinking many people at here concerned about some kind like content in machine learning. So can you show a slide and some kind like what model the student must to know basically in machine learning? I think many people at here may be concerned about it. So can you explain and repeat it before? And then
yeah, sure.
Go to yes, how to teach it, and they use experience, and also take example for make it understanding. Do you have the slide for us and content go along to?
I think we already uploaded some slides, and towards that end, and we also have math slides, which are, as I said, are full of math for math-loving people. But the thing is that both slides teach the same basics, right? So when we talk about machine learning, what do we think, right? We think of linear regression. We think of maybe some neural networks. But these are no longer the state of the art, right? These are when I started my PhD in 2011, they were not considered state of the art back then. So they are not considered state of the art now. Definitely, you need to teach them to students that are coming into the topic, but it's more important to have the pipeline in mind, right? The pipeline is always the same. There is an input, there is an operation, let's call it operation box in the middle, and there is the output. And once students get into that notion that every problem, every classification problem they meet, regardless of the machine learning approach they want to implement, it can be trimmed down to this basic example, right? And from that basic example, what we do is we teach the operations box. What do we have there? Linear regression, how does it work? We have SVMs, how do they work? Then, as I said, we go into neural networks, and deep learning networks are the next, like the natural evolution of neural networks. And then you have all this new different stuff that has happening outside of that. So on the before part, we have the data pre-processing, right? We have the data cleaning, we have the all the different procedures we do in the data to prepare them to go into our operation box. And on the output, we have all the different methods. We have ensembles, we have weighted ensembles, we have neural network ensembles that can join all the outputs of different operation boxes together. So in a sense, nothing changes. The idea is the same as it was. You have some data, you process it, you put it inside your operations box, mathematical operations box, and you get an output. So, but in order to get to the state of the art, you have to teach the first methods that did that thing, right? Because machine learning and the mathematics behind it exist long before we developed the tools to implement them into computers, right? And that's the reason we're always gonna need math. And this goes back to our first topic, right? How deep we go into math, right? How deep we go. Do we go all the way deep and start from 1964? When we're going into LSTMs, do I go and teach the 1998 mathematical paper that defined the first LSTM? Or do I go and show an image of an LSTM and how 3 RNNs cooperate inside it and blah, blah, blah? Oh, definitely, yeah. So let me give you an example of our slides because I have them all here. And let me share my screen as well. Nope. Okay. And share screen. And what screen should I share? I think this one. Okay. And these are some of our slides, right? And you'll see that we have all sorts of basic ideas behind machine learning networks. Bootstrap, hypothesis testing. Someone could say that it was very important before. It still is important in certain sciences. Psychology departments use a lot of hypothesis testing into their papers. Resampling and so on. Then we have smoothing regressions, we have lassos, we have GLMs. We have all the basic stuff that you expect from a machine learning course to have, right? Then if we go to another one, some clustering, supervised and supervised learning. Again, and probably Matt can see that, or anyone who's read through Matt's slides. Very similar stuff, right? And then we have the NIST example, right? The most common image classification task, right? And these are sort of the stuff we believe that should be taught in a machine learning course, but definitely complemented by a certain level of labs. And that level, going back to my first question again, how much lab is enough, right? Again, the slider, imagine it as you have like a sort of like small function, and it's like goes like, oh, do I go towards applying labs, or do I go towards theory? And let me open, Matt, is it okay if I use one of your slides, please?
Yes, of course.
Okay, give me 1 second because I have it somewhere. Open. Okay. And this is one of Matthew's slides, right? Very comprehensive, a lot of mathematics, but still the same stuff. So if you go somewhere in the middle, you see again the same thing. Underfitting, overfitting, bias and variance. It's always the same stuff that governs machine learning. As long as we use backpropagation, nothing will ever change. What's happening though is that some people at IBM are saying we're done with backpropagation. But when and if we're done with backpropagation, we can go and redesign the model, right? But as long as we have it, it's always going to be the exact same stuff. It's going to be a matter of minimizing losses based on a certain loss function, minimizing overfitting based on the training we do, right? And these are the sort of stuff that should be taught in, and then again, you can see that we have logistic regression, we have support vector machines again, sort of like stuff you would expect from machine learning basics course, right? And sorry about using your your slides, Matt.
Yeah, Yannis, one thing I would add is that in the sessions back in Athens, we, as a group, we agreed to add labs to this course. So the version that you see here is it's lectures, tutorials, and then Python implementations of each of the topics. But now we're in the process of adding labs. So there's going to be a little bit less emphasis on the mathematical foundation and a little bit more emphasis on getting things to work in the lab. So anyway, so that's the way that we're already going to be moving with this course due to the input of the consortium.
Yeah, makes perfect sense. Anyone else want to add something, discuss something? No one? Well, I think that therefore we can all agree that a proper computer science module needs both the science aspect and the application aspect, right? And depending on what both student needs and professor needs, we can sort of like not edit, but like modify the module in a way that suits student needs first and our needs secondly, right? And that's the key point I wanted to make with this talk, right? Like, because I've had good experiences and bad experiences, which once again do not have to do with the person teaching the class, but more on my expectations on the class and how I was called to assist on the lab teaching, how I saw students struggling with certain stuff inside the lab. So there are some students always like the pace, we have to follow a certain pace, but usually that pace is set by the person that goes the slowest, right? So that's why we introduced the preparation classes here in Nottingham, because we want students to have a certain understanding of the tools we're going to use. And it's something like they're going to have to deal with in their positions in their employment, right? When they go into a job, they have to get familiar with the tools before going into applying their knowledge and stuff like that. But then again, as Marcelo said, we also need to strain and like give them the appropriate knowledge, because believe me, here in UK, it's not that there is lack of science that students do not choose to get into the academia. Somehow, PhDs and post-PhDs posts are associated with immense levels of stress, right? Immense pressure, but it's not like that. From my perspective and the persons I've worked with, it's always the most creative post I've ever had in my life. Because given all my science background and the application I was taught inside all the modules I was taught, I can apply my abstractions and my knowledge into different problems all the time. And mindful, and this is another good part, like much as we adore certain like approaches, and of course Andrew and G and Li Chun all had the different level of influence in the machine learning topic, right? Like they're both like legends and stuff. There is always room to improve our way of handling students, right? And this is like another topic, but still pertains to the teaching part, because I've taught students that were going under so much stress that we're going into shocks, stress shocks inside the class. Andrew Ng is one of the guys who wrote in Instagram once that I expect all my students to work no less than 170 hours a week, or something, 70 hours a week. And we're making fun with one of my guys in the lab that these are the hours I'm barely awake throughout the whole week. And this pressure adds to the students, right? So there is certainly stuff we can put inside the modules, but it's certainly stuff we can improve when we teach the modules as well.
Just to add something, based on the structure that Yannis described before, what we did is that we followed the structure that we developed here in Athens when we had the visit. And for every one of the different chapters, we have uploaded the specific slides. Also, Matt has uploaded the specific slides. And it means that maybe for machine learning, if you want, we may combine them. Or Matt, actually, it's up to you if you want to describe something about the content that you have uploaded.
Yeah, I would very much like that we integrate these materials. I can see from Yannis's quick read through that there's definitely some useful examples and so on. So yeah, I think I hope that the machine learning team on our side can take this input and add our own to it and come up with something even better. And also, of course, adding in the coming months, we have to design about 12, 13 lab sessions, right? Which I hope where I'm at will be helping me with that. Can we maybe hear from some of the other colleagues that are going to be teaching machine learning at the other partner institutes?
May I have a question?
Yeah.
Hello. I want to know your opinion about giving the assignment, because many of the slides is about on the math side. So do you think is it necessary to give an assignment to students where they have to make a program, coding, implementing, I don't know, linear regression, for example, or naive Bayes or something? Not only using the library, but really hands-on, I mean, making the codes, I mean, like calculating the weight and so on. What do you think?
I think all of us would probably agree that that's essential. Yes, that we must give very strong assignments, take-home exercises for the students to perform. I don't know what others think, but there are at least two ways to do it. One is as a laboratory and a lab report, and then the other is as a separate take-home homework assignment, right? We can do both of these. I'm sorry, I didn't upload any of my sample homework assignments, but yeah, we would have several during the semester. And I'll be sure to upload some samples of those that we can start with. And then, yeah, if Johannes has anything along those lines, that would be great also. Yeah, I think it's very important.
Okay.
Well, how it works in our university here in Nottingham, what we do is we have, let's say 100 units per module. And at the end of the module, there is a 1 week assignment where students can get up to 10 points or sometimes 20 points, depending on the difficulty of the task. And they have to provide some sort of like program. But the thing is that when you have big classes, for example, we have a postgraduate course where we have 120 students. You can imagine that the person that's going through that 100 essays that are code 100% is going to be very it's going to be big burden to you just before the exams, right? Mind that you have the exams coming in as well. So you have to like sort of balance everything out. And still, you need the labs as well, right? Regardless of the assignments, you still have to do some labs, as Matt said.
Okay, thank you.
You're most welcome. Anyone else?
Can I ask you? I would like to ask you about when you assign homework or take home, you give examples, small one or the big one of data. You give your student the big one or the real case study, or you use UCI data when you teach machine learning. Please recommend us. Yeah.
Yeah. So homework is not something we do per se here at the University of Nottingham. We do want students to like go home and dwell in the problems we give them, but it's not like we assign them certain tasks that we expect next week to be completed, right? It's more like you come into the class, we teach you some theoretical stuff. Same week, you have a module that's inside the lab, talks about the theoretical stuff we talked about in our slides. Next week is a step further. And next week is a step further. And when the module concludes, that's when we have a certain project, that's how we call it. We call it a module project, where students have to apply the whole knowledge we gave them. Regarding the data, one of the parts of a machine learning module is data sampling. So it doesn't have to be too much data or too few data. With the recent advances in data augmentation as well, if you choose you want to teach some part of it, you don't have to give a lot of data. Even a small data set of, let's say, 100 examples is enough to test whether students got a grip on the stuff you taught them throughout the year. But this is like complementary to the exams as well, because the usual exams, they happen with a multiple choice format. And the multiple choice format has negative points. So students who want to randomly choose stuff are more afraid that they're going to lose marks, so they don't do it. And multiple choice is proven to be the best way you can test not students' memory, because if you don't want students remembering the stuff from the heart out, you want them to critically think on each example you set them out to, right? Does it make sense?
We have any question?
Can we maybe poll some of the partners? Can we move to? Let's see. We had an input from ITV about USU or UNCIA. I see Ernest here.
May I ask some questions? I am Kamron Sonat from KKU too. The content of this lecture is based on mathematics. There are a lot of mathematics, a lot of formula, and how to connect between the assignments and the lecture.
Well, to tell you the truth, it's always difficult, right? But to me, I think the best approach is either the same week, if it's not doable the same day, to have some sort of lab that connects everything. You probably know of Notebook. Notebook is a good example of software that can be used for teaching. I wouldn't recommend it for development purposes, but for teaching, you can implement it inside your lecture, where, let's say, you teach linear regression, and you have to remember that as beings, as human beings, we are visual perceptive, right? We perceive better stuff that we can see. Some of the examples we included, they have graphs on purpose, so students can see how a linear regression function looks, right? How overfitting looks, how high variance looks, how low variance looks. So my best approach, if I was designing the module, would be to have some theory, and at the same time, without leaving the class and without requiring students to open their laptops or the computers to start testing stuff out, you include both a visual representation of the formulas you used and followed by a small PyNotebook session where you show them an example of the code that does that operation you showed them as a mathematical function. But like, it's not always doable, right? Because inside the module, you have to teach a certain amount of stuff that the students are going to use into the next module or the next semester, the next year, or the other postgraduate studies they want to choose. You don't want to leave stuff out. So sometimes it makes the pace of the course difficult, because you have to cram all this stuff together, too much stuff on top of the other, and nothing will go through in the end, right? So in another perspective, it's better to leave it as separate theory and implementation. But it's always up to the person teaching the module and the students, right? Because remember, it's different if I go to the best university of Europe and teach students that have deep understanding of mathematics a topic, and different if I go to undergraduate students that had low A levels and try to teach them fundamental mathematics, right? So it's always a matter of teacher and students, sort of like the contract we sign, we never sign though, right? Like figuratively.
Maybe I could like to add something also to this question from Kamran. So maybe I can share my screen now. Oh, I have to come back in a moment. Maybe someone else can talk for a minute while I connect via Zoom. My Zoom is not ready yet.
From experience though, until Matt is ready, here we don't use actual code a lot during the teaching of the course. We prefer to keep it into the lab setting. But as I said, it doesn't hurt to put some code in it. For example, if you start and show all the different layers of deep learning, it wouldn't hurt anyone to include how all these layers are implemented in Keras or PyTorch, right? It wouldn't like be so difficult. It would give students like, oh, it's that easy. Is it that easy? Because I can show you the math. Oh, Matt is ready. Let me conclude, Matt, really quick. I can show you the math behind the dense matrix theory, but I can more easily show you how a single line in Python handles everything. And that's whenever you're ready, Matt.
Yeah, thanks, Dennis. Yeah, I guess I fully agree with that. So on this page or this folder in the shared space, so I put up the PDF slides that have all the mathematics, as Dennis pointed out very well. But yeah, so then each of what I try to do at least is for each of the topics that we talk about in the class, then I would usually give the students a Python, a Jupyter notebook that actually goes through the details of implementing that concept and showing how it works in actual code. So for example, if we were talking about underfitting and overfitting, for example, right, then you would go to your Jupyter notebook and then find the exercise in overfitting and underfitting. And so then we would show code, right, that creates a data set of some kind or loads a data set from one of the public repositories, reviews the mathematics, right, briefly, then shows how to do some visualization, right, using the tools that are available there, how to come up with the model, fit the model to the data, and then explore the different concepts that are being brought out in the lecture. So, I think this is one of the one of the ways that you can take the mathematics and make it very grounded, right, in code that, well, maybe this code is a little bit too long, longer than it should be, right? But then, yeah, same thing for, say, for neural networks, as Jonas was saying. So then you can actually, see how to implement your own neural network without Keras or PyTorch or any toolkit at all, but to just implement the equations from scratch, right? So there's some examples here that any of you are interested to take a look at.
Yeah, that makes perfect sense. Like, especially the part where you show them how from the simple mathematical functions can go into a neural network, because this will ascertain that students have the grip on the theory before they start and go into sklearn and just input the library and create everything. Like this is perfect. And it's to be expected, because like Matt has all these years of experience on teaching that he would get. And still you can see that all the graphs and the mathematics can be combined in a single notebook and can show the students how you go from the theory we taught in class to the actual code to the visual interpretation of the stuff we're doing, right? Sometimes it's easy, sometimes it's hard. Like there might be some classification tasks that go to our fourth space where you can't easily visualize it, but you definitely can visualize the bias and the overfitting procedure easily every time. Anyone else? The audience doesn't seem a lot lively today. Why? Is it because it's Monday or something? I only wonder what would happen if it was like late Friday, right?
Because it is in the evening in Asian.
Ah, that's why. That's why. It's after 5,
It's
right?
evening, just
After office hours. Okay, okay, makes
a little
sense.
bit sleepy now. You have to make fun, right?
Yeah.
Have to
Okay,
make fun.
okay. Well, I don't like to repeat myself. Most of the stuff. Oh, yeah.
One question. From my experience in Crowden, there are a lot of students cannot understand what the neural network is. And once we go further to the deep learning, it's a lot of confusion. They cannot imagine how to explain it. The perception is very, very difficult.
Let me tell you that from colleagues in computer science, and I'm not trying to defame them, I'm more trying to say that how the topic is. This is what I like about computer science, right? It's a science, but we can be philosophical about it. So if I ask you, would you consider a recurrent neural network as a deep network? What would your answer be? Because we know it only has one layer. It's like a simple neural network, but it has a memory in it, right? Do you consider that memory being a separate layer, or do you consider it a part of the layer itself? So in that sense, there are still people in computer science at the professor level where we discuss these things out. And as I said, neither is wrong or right. It's a matter of perception. Regarding the students that have difficulties understanding neural networks, the thing is, like, as academia, it's not high school, right? We can't go in to every student, give them exercises and expect the next day to correct these exercises and stuff. We sometimes have to be dependable on whether the students themselves are going to generalize, right? The process of machine learning generalization. Is the student going to be able to take the small seed we give them and make it a plant by going into the topic and starting reading themselves? Because obviously I don't know everything. As a matter of fact, I know nothing. More so, I can't teach everything. The student, I will give them like a sort of starting point, and the student has to go into that. Now, the question is, how can we further enhance that learning process that happens outside of the classroom, right? And one sort of like solution could be a group project, right? Where you only have to do, let's say in 100 students, have only 5 projects to grade afterwards. It would make sense for you. So you give them a group project and you expect its completion within 4 weeks. And you can assess at that point inside the groups, which group had the most difficulty, which had not. But still, if you have multiple modules teaching in the university, you can't have the same thing for every module you teach, right? If you have, it's usual that professors here teach 4 to 6 modules. You can't have 30 different group projects to be graded every other week. Sometimes you have like to, how can I say it? You have to believe in your students, right? You have to believe that you're doing the best you can in the classroom, and they take the best of you outside the classroom, right? They have to work on their own, how do you call it? Their own, not imagination, their own discovery of the task, right? They have to discover some aspects of it, because neural networks, believe me, they're not as complex as LSTMs, but the mathematics of neural networks can be a bit too much for some students, right? So there you have a choice. Do you go into more math, Do you go into lower level math where, for example, you have to teach some fundamental statistics before you go into neural networks? Or do you go to a more implementation approach where you teach them how they're applied, where you show them graphs of how they're connected, of a fully dense layer connected to the output layer, of the simple weights, and you don't dwell too much on the math? We always have to be like self-adjusting, right? You have to adjust the module to the audience you have. If that makes sense.
Yes.
But then again, I didn't answer your question, right? There is no, sorry about that. I don't think there is a single answer to that thing. It might be like disheartening because you're putting yourself into the course, into the module, and all your heart and everything, and you see students struggling. But there is not much you can do outside the class, right? If the city you live in has a strong nightlife, you're gonna expect the students preferring the nightlife, right? Sometimes.
With nightlife, we get drunk.
I think that's like within the goals of an undergraduate student, right? When they go into the uni, learn stuff, get drunk, and everything.
Yes.
Miss Erna Nababan. I thought Greek surnames were hard. I thought. Anyway.
Okay. Hi. I just want to ask you how to evaluate student understanding on the topic given in class. One way is to give them a programming assignment maybe, but the student ability is different. Every student has different ability in programming. So what can I do? I mean, in the case of the student have a very low ability in programming, maybe like that.
So I said earlier that what we do here in the university, we have some preparation classes for the master courses where people go into and develop the tools. But this process happens inside the labs here in our classes. So inside the lab, not only we teach how to code and how to bring that theory into application, but we also perform small exercises, not from like start from scratch and create this model, but small stuff that tests student knowledge on small topics. Again, it's not easy if you have a big class to go into every student's needs. Like the older we grow, the more fed up we are with the student emails, right? So at some point you have to have, as we said, as students have their psychological balance, and we have to be aware of that, not overstretching them too much, not putting so many exercises on them. The same is for us, right? We have to protect ourselves from dealing with classes 24/7, right? Because there is this sort of like, in my view, bad work ethics in UK where you have to work from home as well. Well, if you have a family and if you have like a life outside the university, you can't like start answering all the different emails. But if you do it inside the lab, you can assess whether a student, and usually in the labs here in UK, we have more than 3 people. It's 1 person up to 30 students. So if you have more students, you have to have more lab assistants inside. And these lab assistants, their task is exactly to identify which student is struggling with what, be there to give advice, but also afterwards to suggest proper learning material for that student. And again, we expect that they do it outside of the classroom, right? We can't do everything into a classroom.
Okay, thank you.
No worries. Any more questions?
Hello, I'm Priyanka. I have a question.
Hi, Priyanka.
Would it be a good idea to introduce interpretable machine learning techniques to the course, especially with the GDPR rule? It is important to select a machine learning technique that deliver interpretable output. What are your thoughts about it?
Could you elaborate, please?
Machine learning interpretable techniques where if you teach the random forest, it's basically like a black box model. We go inside and see what's happening inside that black box model, especially with the machine learning interpretability, partial like visualization or global interpretability, or like something like LIME approach. Do you think if we teach them, is it like overloading the curriculum, or just it's kind of like a state of art in the machine learning? So what are your thoughts about it?
I'll tell you what. So I remember 2 years ago, I was having an interview with a university in London, and it was the medicine department, right? And they wanted to start implementing machine learning to do some tasks, mostly like it was about sepsis. Sepsis is like a certain thing that happens in our body, and we start to decay and die. The thing that struck me the most was that during the interview, we had a talk on machine learning, and they said, we know what machine learning is. It's something we drop into a black box and gives us a classification. But it's wrong, because it's not a black box. It's not magic that happens in it. Well, if mathematics is magic, it is magic that happens in it, right? But it's human magic. It's stuff that we can both teach and interpret given the proper background knowledge. So I wouldn't say I'm for or against. I don't have much experience in interpretable learning. I don't like the black box idea, because I don't want students to think that something happens in there that is beyond their grasp, of mental grasp, I think, right? Like everything that happens inside even the most complex deep learning network, even a network with 152 different convolutional layers, there is stuff that you can interpret that happens inside each layer. But I'm not the most experienced in the topic to answer that.
Thank you. That makes sense.
Thank you for your question. Any others? Okay, then, since we don't have any more questions, I wanted to thank you all for attending. I hope that my little to none knowledge on teaching helped you decide on the proper module design. I hope that your students are in awe of you. They see you as a role model and not someone who is very distant. And I hope both you and your students have a normal and easy module course. Thank you all for your attention. Thank the Athens University for inviting me.
Giannis, before you leave us,
yeah,
can we ask more questions?
Yeah, sure, definitely. If I can answer them.
I think I'm pretty sure that our colleagues, they would love to hear your thoughts more, right? But maybe don't have the right question in their mind yet, right? So one of the things that I'd like to know your thoughts on, especially you're working in the UK, right? And I'm wondering how in a course like this would you go about connecting with the local industry, right? Like either getting problems from local companies or using your consulting or something like that to as a route to bringing that back into the classroom. Do you have any experience with that?
Well, definitely Strathclyde University in Glasgow was like a very different experience for me because it was a very business oriented. That would mean that our building had a reception with people showing the building around to CEOs and all the important people of industry, right? They even had a separate department where they would advertise the knowledge of the university. But this is like more of a country culture because here in UK, the knowledge transfer partnerships are so common, and they're common because industry knows that they can get quality employees out of graduates from the universities. Whereas in Greece, which is like a whole different culture, we have especially good academics, very researchful, like they publish a lot of papers, very high H indexes, high I indexes, high ref scores, high everything, but there is no connection to the industry. And this again is not like solely on the academia sector in Greece as well, because here in UK, the public sector, work in the academia per se, doesn't get you as a big salary as a work in the private sector. So this on its own is a sort of motivation for the graduate to go and look for a work outside the university, right? If that makes sense. Whereas in Greece, which is the other end of the example, the salary you get on the public sector is way higher than you get on the private sector. So the student would be more inclined to follow an academic career than going into the industry. From the university side, and not so on the teacher side, because as a teacher, you can probably like have some personal connections that you can take advantage. Like it's not taking advantage, you are exchanging stuff, you are giving them knowledge, and they get a profit out of the student you bring them into. You can probably like work on that end from a personal point of view and create some sort of connections. But if the university itself doesn't have a certain policy in mind that we want our graduates to have this percentage of graduates working within the next 3 months, then I think it's difficult for the person teaching to be able to have some sort of definite impact on the topic. It's more on the university's policy or on how they can assist that industry to academia connection.